So this is the question, very important one. The question is a 9.375 gigahertz uniform plane wave is propagating in polyethylene with the standard value of epsilon r is equal to 2.26. If the amplitude of the electric field, they have mentioned it as 500 volt per meter, and the material is assumed to be lossless. We need to find these things, that is phase constant, wavelength, velocity of propagation, intrinsic impedance, and magnetic field intensity. Okay, so these are the 5 things which are going to find. So in the derivations and all, we have seen the relationship between these things, right? So the first thing is, let's find the phase constant. The formula for phase constant is omega square root of omega mu naught, since this is in free space, sigma by 2. Okay, so now in order to find this beta, we don't have any values for omega and sigma. The standard value of mu naught, we know that it is 4 pi into 10 power minus 7. So we know that the value of omega is equal to 2 pi f. So omega is equal to 2 into 3.14 into f. The frequency they mentioned it as 9.375 gigahertz. So 9.375 into 10 power 9, giga means 10 power 9. So if we solve this, the omega value, we are getting it as 5.88 into 10 power 10 radian per second, its unit. Okay, it's mentioned it as referred as radian per second. So this is the value of omega. Similarly, sigma is equal to 1 by neta. Okay, since neta is the intrinsic impedance, okay, in free space the value of neta is equal to we have seen it as it is 376.7, right? So that's why sigma is equal to 1 by 376.7, and approximately the answer, if we simplify, we are getting it as 2.65 into 10 to the power minus 3 mho per meter. Okay, so this is the unit for sigma conductivity. So now these two things we are going to substitute in this equation back, that is square root of, so I have substituted the value of omega, sigma and mu naught. Okay, and if we simplify this square root, the answer for beta we are getting approximately as 9.892. okay, so this is the value of our phase constant beta. So similarly, in the next case, they have asked, second sub question, they have asked to find us the value of wavelength lambda. And lambda, we know that we have a formula, that is c by f. Since f is equal to, since lambda times f is equal to c, so that's why lambda is equal to c by f. So lambda is equal to c. Okay, so in order to find the c, that is velocity of propagation, so first we need to be finding the velocity of propagation in order to find wavelength. Okay, so that's why first we need to be solving the third sub question to find the value of c. We know that velocity of propagation, the formula is omega by beta. So c is equal to omega, just now we have calculated, that is 5.88 into 10 power 10 divided by beta is equal to, just now we have got 9.892. okay, and if we simplify this, we are going to get our answer as 5.94 into 10 power 9 meter per second. Okay, so this is the value of velocity of propagation of light. So this value we are going to substitute back here. Okay, so the value of c is 5.94 into 10 power 9 divided by frequency. In the question they have mentioned 9.375 gigahertz. Giga means 10 power 9, so we can cancel these two, and when we divide this, the answer we are getting it as 0.63. the unit of wavelength is meter. Okay, so this is the answer for wavelength and velocity of propagation. So in the next question, they have asked to find out the intrinsic impedance. So they told us to find the intrinsic impedance, that is neta is equal to Ey by Hz. Okay, so for this Ey by Hz, from the derivations here, from the intrinsic impedance of free space, so we have got one relation, that is Ey by Hz is equal to c times mu naught, right? We have derived this equation. So that's why Ey by Hz, we need to be substituting the values of c here, which we have got, that is 5.94 into 10 power 9 into the mu naught value, standard value is 4 pi into 10 power minus 7. So if we solve this, our value of intrinsic impedance we are getting is approximately 7.46 kilo ohms. Okay, since impedance is represented as the unit is ohms, so this is the value of intrinsic impedance. So similarly, the next sub question they have mentioned it to find the magnetic field intensity, that is H. Okay, so we have one relation between Ey and Hz, that is Ey by Hz is equal to, just now we have got it as 7.46 kilo ohms, right? But in the question they have mentioned the amplitude of electric field as 500 volts per meter. So that's why 500 by Hz is equal to 7460. So therefore what we can write it, Hz is equal to 500 divided by 7460. 10 get cancelled. So 50 divided by 746, if we simplify, approximately the answer we are getting it as 0.067 amperes per meter. Okay, so this is the value of magnetic field intensity. So like this we are going to solve this problem. Okay, all the 5 sub questions we have solved. So hello everyone, welcome to this new session. So in this session we are going to discuss we are going to continue with module 5 only, and we are going to discuss one more concept which is related to uniform plane wave. Okay, that is the movement of electric field intensity and magnetic field intensity is uniformly distributed along the surface. Okay, what is the relationship between them when they are moving in a uniform field or uniform plane wave? Okay, so first the definition of uniform plane wave. Uniform plane wave is defined as in these 4 points, that is, first point is electric field intensity and magnetic field intensity are uniform in nature with respect to uniform plane wave. Second point is that E and H are perpendicular to each other. Third point is that E and H are in one single plane. Okay, both the electric field and magnetic field are induced in a single plane. Okay, in that single plane its condition is that it needs to be uniform in nature. Okay, and this E and H are perpendicular to the direction of propagation. Okay, in this figure you can see these are the directions of propagations here, which this indicating arrow. These are the directions of propagations. Okay, so now let's see what is this concept of uniform plane wave. So let E be in y direction and H be in z direction. Okay, that is electric field and magnetic field, let it be in y and z direction respectively. Okay, and let X be in the direction of propagation. Okay, so this is the direction of propagation here, X. So E is equal to, in generally, Ex Ax plus Ey Ay plus Ez Az. Same goes for H. Okay, so now a uniform plane wave, that is UPW in free space. For free space we have some conditions, that is mu is equal to mu naught, epsilon is equal to epsilon naught, and sigma equal to 0. As same goes with Jc is equal to sigma times C is equal to 0. Okay, the conduction current density, conductivity and permittivity would be in free space, that is mu naught and epsilon naught. So now let's consider the Maxwell's equation, that is del cross E is equal to minus dou B by dou T. So this relation which we have got from Faraday's law, consider that equation, and here in this case B is equal to mu times H, but in free space mu equal to mu naught, so that's why minus mu naught dou H by dou T, since B is equal to mu naught H. Okay, so now this del cross E, substitute it, take the determinant, that is Ax, Ay, Az, dou by dou X, dou by dou Y, dou by dou Z, 0, Ey, 0. Okay, since we are considering UPW with E in y direction and H in z direction. Okay, since we have considered this E in y direction here, so that's why, since we have a del cross E, so that's why the y component would only be activated, the rest of the two components would be 0, so that's why these two are 0. That's equal to mu naught dou by dou T of Hz. Okay, because I have taken H in z direction, right? So that's why this H would be replaced by Hz into Az vector. These two components would be neglected, only this component would be left out. Okay, and X is the direction of propagation, so that's why Ex equal to Ez equal to 0, Hx equal to Hy equal to 0. Okay, because we have taken E in y direction and H in z direction, so that's why the rest of the two components are equal to 0. Okay, so now after taking its determinant, so this is the expression which you are getting, that is dou by dou X of Ey into Az vector is equal to minus mu naught dou by dou T of Hz into Az vector. Az vector, you can cancel it out from both sides, so the remaining term is dou by dou X of Ey is equal to minus mu naught dou by dou T of Hz. Okay, so whatever this equation you've got, you name it as equation 1. So this is the plane wave equation which we've obtained when we take the electric field and magnetic field in a direction along with the direction of propagation in a particular direction, that is y. In this case the electric field is in y direction and magnetic field is in z direction. So that's why if we see the relationship between them using the Maxwell's equation for uniform plane wave in free space, so this is the equation which we obtain. Okay, so that's why you can name it as equation 1, because this is further many more steps are there for this. But for in case of only for uniform plane wave propagation, okay, if they ask, this much is enough to write from here till here. This one full page is enough. Okay, if they ask for 10 marks or something, still more further derivation is there. So that's why I have named it as equation 1. So hello everyone, welcome to this new session. So in this session we are going to discuss with one more important concept, okay, from module 5. Till now we have covered most of the concepts in our previous videos. Those who have not seen it, you can first refer those videos and then you can see this one. Okay, that is Poynting vector or Poynting theorem or power flow. Okay, so these are the different names for the concept. You can simply remember it as Poynting theorem. Okay, yeah. So now what is this Poynting theorem? So as EM wave or electromagnetic wave propagates through the space from source to distant receiving point, there is a transfer of energy from source to receiver. Okay, that is, the energy is being transferred from one point of the source in a particular electromagnetic medium. Okay, it is transferring of energy is taking place from source to the receiver. Okay, there is a simple and direct relationship between the rate of this energy and transfer of the amplitude of electric field and magnetic field strength of electromagnetic wave. So what is this relation here, the transfer of energy which is taking place? We have a certain amount of relation for that we are going to discuss right now. Okay, so now from Maxwell's equation we know that del cross H is equal to JC plus JD, that's equal to sigma E is equal to sigma E plus epsilon dou E by dou T. Okay, where JC is equal to del cross H minus epsilon dou E by dou T. Okay, that is del JC, if we take individually, if we take JC, we using this equation, this is the equation which you are getting, that is del cross H minus epsilon dou E by dou T. So now for this equation, multiply the E component on both sides. Now what we are getting, E dot JC is equal to E dot dou H minus epsilon E dot dou E by dou T. Okay, after multiplying E on both sides. Now from a vector identity we have a relation, that is del dot E cross H is symmetrically equal to H dot del cross E minus E dot del cross H. Okay, so this is one vector identity. Okay, those who are not knowing this one vector identity in vector algebra, during a 12th standard you might be studying the relationship between the curl and divergence. Okay, sorry, dot product and cross product. Okay, if you use that relation, this is one relation which we get here for electric field and magnetic field. So now substituting E dot del cross H, what we are getting is E dot JC is equal to minus del dot E cross H minus epsilon times E dot dou E by dou T plus H dot del cross E. Okay, in this equation here. Okay, so now this is equal to minus del dot E cross H minus epsilon E dot dou E by dou T is equal to mu times H dot dou H by dou T. Okay, since del cross E is equal to minus dou B by dou T here. Okay, and B is equal to mu times H, so that's why in place of del cross E we need to be writing it as mu times dou H by dou T with the H component. Okay, so now our E dot JC, what we are getting is E dot JC is equal to minus del dot E cross H minus minus of epsilon E dot dou E by dou T plus mu H dot dou H by dou T. Okay, so this is so here we have one minus sign here. Okay, since what to say, dou E is equal del cross E is equal to minus dou B by dou T, so that's why we are getting here minus sign. If we group these two together, we can take this minus sign common outside and we can write it like this, that is epsilon E times dou E by dou T plus mu H dot dou H by dou T. Okay, where this epsilon E and mu H is equal to D and what to say, B. Okay, so that since D is equal to epsilon times E and B is equal to mu times H. Okay, so this is the relationship between electric field intensity, electric flux density, magnetic field intensity and magnetic flux density. Whenever we have any magnetic field or transfer of amplitude of magnetic field with respect to electric field, okay, that is the relationship between E dot, in this case we have taken JC component, okay. Yeah, if we take JD component separately, the term which we are getting is not the same. We will be getting some changes here, okay. So now further what we can do is E dot dou E by dou T is equal to 1 by 2 into dou E square by dou T, and also H dot dou H by dou T is equal to 1 by 2 into dou H square by dou T. So now replacing these two terms in this particular equation which we have got, so that is E dot JC is equal to minus epsilon by 2 into dou E square by dou T. Since we have epsilon here in this equation, if you check here, we have epsilon times E, also mu times H, okay. So that's why this is epsilon by 2 dou E square by dou T plus mu by 2 dou H square by dou T minus del dot E cross H, okay. So now integrating over a volume, this whole equation, if we integrate over a volume, what we are getting it now is volume integral of E dot JC into dV is equal to, here now minus dou by dou T, you take it common outside and bring this volume integral here, that is volume integral of epsilon E square by 2. Here in this equation I am taking minus dou by dou T common outside, I am taking outside of this equation, so that is epsilon E square by 2 plus mu times H square by 2 into dV minus volume integral of del dot E cross H dV, okay. So that is volume integral of E dot JC dV is equal to minus dou by dou T of volume integral of, again this term, epsilon E square by 2 plus mu H square by 2 dV minus, now this term is replaced by surface integral of E cross H dot ds. So how it's replaced is, if you see here, in place of E cross H here, I am just replacing this E cross H by d, okay. Since we have the relation of divergence theorem, that is del dot d is equal to volume integral of del dot d dv is equal to surface integral of d dot ds, okay. When we replace this E cross H by when we replace this d as E cross H, we would be getting the same relation, that is volume integral of del dot E cross H dv is equal to surface integral of E cross H ds, okay. So that's why I have replaced this term. So in this case d is equal to E cross H, okay. So here split this equation into three parts, name this as 1, this part as 2, this whole part as 2 and this whole part as 3, okay. And we have individually, you can define those three components as, this one represents the instantaneous power dissipated in the volume, that is E cross I by A, that is power by area. And this equation 2 represents the rate of decrease of electric plus magnetic energy, okay. Rate of decrease of electric plus magnetic energy, since we have this whole equation we are mutually integrating with respect to V, and also we are partially differentiating this with respect to time. So that's why we are getting rate of decrease of electric plus magnetic energy, okay. So now according to the law of conservation of energy, we know that the rate of energy dissipation in volume V must be equal to the rate at which stored energy in the volume decreasing plus rate at which energy entering the volume from outside, okay. That is, this law of conservation of energy states for the rate of energy dissipation of increase as well as decrease of the electric and magnetic energy at the same time, okay. So therefore we can conclude that the surface integral of E cross H dot ds is the rate of flow of energy inwards, and also we can, this is in minus sign, okay. Also plus surface integral of E cross H dot ds is the energy flow outside the volume, okay. So we can finally conclude the relation of Poynting vector is equal to P, Poynting vector is represented as P, is equal to E cross H, okay. So this is the relationship of Poynting vector here, okay. Is called as Poynting vector, power theorem or Poynting theorem, one and the same. This was the whole derivation of this Poynting vector, okay. So hope you understood this very well. So that's all for this session. Please like, share, subscribe and refer our playlists, okay. So we have uploaded the playlist for all the other concepts of this subject, that is electromagnetic theory. Also if you want to refer other subjects related to PCS, control system and microcontrollers, we have the playlists available in our channel. It might be appearing on the right of your screen now, so please do refer those as well. Also, you can support our channel by commenting down your precious opinions about how the classes are going on in this channel. Okay, what are your interests, and you can comment it down. So please support us guys, like, share, subscribe. Thank you. Okay, which is a direct problem and very important problem. They might be asking as a sub question for some of the derivations of this module. So that is, if sigma is equal to 58 into 10 power 6 mho, MHO. Okay, MHO is the unit for sigma. Okay, since conductivity is equal to 1 divided by resistance, and the resistance SI unit is ohm. Okay, for conductivity it is expressed as mho. Okay, MHO, that is mhos per meter. At frequency they have mentioned it as 10 megahertz. Determine the depth of penetration. Okay, so simple, this is a direct problem. So this is in free space. Okay, in free space. So the depth of penetration formula we have discussed in the last session, that is square root of 1 by pi f into mu naught sigma. Okay, in place of free space, so we are going to replace mu by mu naught, and we know how we have a standard value of mu naught, that is 4 pi into 10 power minus 7 ampere per meter. So substitute the value, dou is equal to 1 by pi, its standard value is 3.14 into frequency they mentioned it as 10 megahertz. Mega means 10 power 6, so 10 into 10 power 6 into mu naught value is 4 pi into 10 power minus 7 into 58 into 10 power 6. So if we simplify this in the calculator, what we are getting, square root of 1 by 2.287 into 10 power 9. So dou is equal to square root of 10 power 9. If you bring it to the numerator, it would be 10 power minus 9. Then if you put this thing in the calculator, so this is the depth of penetration which we obtained, that is 2.05 into 10 to the power 2.09 into 10 to the power minus 9, or simply we can write it as 20.9 micro. Okay, yeah. So this is the simple depth of penetration problem. So you can note it down. Okay. So hello everyone, welcome to this new session. So in the last few sessions we have started with module 5, and we have covered many important concepts in module 5. So those who have not seen that video and who are new to this video, you can refer those 4 videos. It is available in our playlist. Okay, so please refer them first, and after that you can refer this video. Okay, so this is the we are coming to the end of this module, and this is the last topic, that is skin effect or depth of penetration. Okay, so now what is the skin effect and depth of penetration? So now we are going to discuss this in detail. Okay, before that let's analyze this figure, that is, so this is the electric field direction, which is I have in y direction. I have assumed it is in y direction, that is EY, and also we can this is the electric field where this curve or the electric field is moving in a particular curve here, and this where this EM wave enters the conducting medium, and its amplitude decreases exponentially and it becomes partially zero. You can see that it decreases exponentially and it reaches to the point where it partially becomes zero. Okay, and where this point where the point decreases exponentially. Okay, where the point which the divergence take place from the x-axis as well as this y-axis, this point is called as 1 by E times epsilon naught, and the length here is called as the depth of penetration, and it is represented by dou. Okay, so this is dou, or we can name it as depth of penetration. Okay, yeah. So now let's see what is this skin effect. So when an EM wave enters a conducting medium, its amplitude decreases exponentially and becomes partially zero after penetrating a small distance. So this is the small distance of penetration here, and this distance of penetration is mentioned as depth of penetration. Okay, whatever the distance made by this exponentially curve to decrease exponentially and partially becoming zero, where the distance between that is called as the depth of penetration. Okay, as a result, the current induced by the wave exists only near the surface of the conductor. Okay, that's why this effect is called as skin effect. Okay, because this current induced by the wave exists only near the surface of the conductor. Okay, not to the whole part of the plane, it only exists in the part of the surface of the conductor, and this effect is called as skin effect. Okay, so now let's analyze this derivation, and let's get the expression of depth of penetration. So now let x be the distance traveled in the medium and E is the amplitude. Then we can see that simple expression of E as E is equal to E naught times e to the power minus alpha x, okay, where this alpha is called as represented as the attenuation constant, okay. You can remember this term, it is called as attenuation constant, okay. Now E equal to E naught, we are getting this relation E equal to E naught at x equal to 0, okay, that is at free space. Also E equal to 1 by E times E naught at x equal to tau, okay, from this figure, okay. At x equal to 0, that is when this curve is at 0, at 0 axis at the origin, we are getting E equal to E naught, and also at x equal to tau here, we are getting the relation of E equal to 1 by E times E naught, okay. So at the penetrating depth tau, i.e. x equal to tau equal to 1 by alpha, okay, and also E equal to 1 by E times E naught. So where this tau is called as the depth of penetration, okay. So for a good conductor, we have a simple expression of alpha, or the attenuation constant for a good conductor, that is alpha is equal to square root of omega mu sigma by 2, okay, where this omega is the oscillating frequency, mu is the permeability in the medium, in free space it is mu equal to mu naught, and the sigma is the conductivity divided by 2, okay, it whole square root. This is the expression for attenuation constant, okay. Now what we can do is, since alpha is equal to 1 by tau, okay, we have a direct relation of attenuation constant and depth of penetration, that is alpha is equal to 1 by tau, okay. So now what we are doing is, tau is equal to, take its reciprocal, that is square root of 2 divided by omega mu sigma. So now what we can do is, tau is equal to square root of 2 divided by, in place of omega replace it by 2 pi f, so we can cancel 2, we are left with square root of 1 divided by pi f mu sigma. So this is the expression which we are deriving for depth of penetration, that is tau is equal to square root of 1 by pi f mu sigma. Also we can note a few things, that is whenever the conductivity increases, the depth of penetration would be decreasing, and also the frequency, when frequency is increasing, the lesser the penetration, okay. Whenever the more the frequency, the lesser the penetration, because the relationship between this tau and sigma and f is that tau is equal to 1 by something, right? So that's why it is always reciprocal to each other and inversely proportional to each other. So that's why whenever the conductivity increases, the depth of penetration would be decreasing, and whenever the frequency increases, the depth of penetration would be always less, okay. So this was a simple derivation of skin effect of depth of penetration, okay.